one is called Rational Exponents. So today we're going to be talking a lot about exponents and what that does. But the whole chapter is called Exponential Functions. Okay. Again, dealing with exponents. And then towards the middle end of the chapter, we're going to get into logs. How many of you have done logs before? No?
The X, Y, D.
Yeah, expanding and condensing. No? Yeah? Okay. All right, so let's start easy. You guys have all seen this before, right? Okay. 5 to the second power just means take that base, multiply it 2 times. Pretty easy, right? So 5 to the third, take that base, multiply it 3 times. Get 125. What if you have a negative exponent?
Times it by a decimal.
No, you want to make it into a fraction by putting a 1 in the denominator. And then wherever your negative exponent's at, you want to move it to the other spot. So right now it's in the numerator, so we're going to move it to the denominator. But if it was in the denominator, you would want to move it to the numerator. So you'd move it to the other place, the other spot, and make the exponent positive. And we know 5 to the third is 125, so it's 1 over 125. How about anything to the 0 power? Okay. Yeah, anytime you see any number or any variable to the 0 power, it's always going to be 1. All right, now let's talk about fractional exponents, like 125 to the 1/3 power, or 25 to the 1/2 power. Okay, basically whatever the denominator is going to be your root. So for 25 to the 1/2 power, this is going to be the second root of 25, or the square root, right? We don't generally write that 2. We just write the square root of 25. And because 25 is 5 to the second, and we're taking the second root, our answer is just 5. Okay. So 125 to the 1/3 power is the third root of 125. You want to guess what 125 is? Or come up here. It's 5 to the third. So we're under the radical. We have 5 to the third power, and we want the third root. So the answer is 5. Okay? This 3 and this 2 is what we call the root, or sometimes you'll see the word index, but usually I just call it the root. And then underneath the number inside, we call that the radicand. And if you have, I forgot to write a 3 right there. If you have a number right here, this is the power or the exponent. Sometimes people will call it the power, sometimes people will call it the exponent. If it's a 2, sometimes people will say squared. If it's a 3, sometimes people will say what? Cubed. Okay, but usually only squared and cubed. You don't hear usually people call it quintic or whatever. They just
say quadratic.
Yeah, it just is weird, awkward to say those. So most people don't. They'll just say 4th power. Okay? All right, so let's do a couple examples. Example number 1, we'll call it easy. Okay? Kind of like the easy ones you're going to see in the book. Okay, so 16 to the 3/4 power. So that means we want the 4th root. So the denominator becomes the root. And under the radical bar, we're going to have 16 to the power of 3. That's our radicand. Okay? So if you take your calculator, hopefully most of you know about this button, the little cheater buttons. So you're going to take 16. You're going to use this little button that looks like a pointing up arrow. And it shows on your screen as the little point up arrow. and then type 3. That's 16 to the third power. And we get the fourth root of 4,096. Okay? Now we just need to take the fourth root. So on this calculator, you have to type a 4 first, because you want the fourth root. And then you're going to hit second, or some calculators it's shift. And then there's two different buttons. One that has the x root and one that's just a regular old square root, right? So if you're taking anything other than just the square root, so the third root, the fourth root, the fifth root, the 28th root, the 95th root, whatever, you want to make sure you get that x in there. And then you can retype this number 4,096, or there's a shortcut where you go second, and then there's this little ANS. That stands for answer. So it's going to take the previous answer, unless you want to just retype it in, hit the equal sign, and it spits out 8 for you. How many of you knew about the answer button? Okay, saves you a couple seconds. Okay. All right, let's try another one. Example number 2. Another what I would classify as sort of easy. 25 to the negative 3 halves. Okay, so right away we have this negative exponent. Remember when we were up here, we moved it from wherever it was to the opposite spot. Okay, so I'm going to make it into a fraction by putting a 1 in the denominator, which means it's going to become 1 over the 2 is the root, and then under the radical we have 25 to the third power.
To the negative sign.
Because it was in the numerator, I moved it to the denominator and made it positive. Would it help me to write it like this? 1 over 25 to the 3 halves? Yeah? Okay. Hi, how are you? Good. All right, now we got some more calculator work. So in the denominator, under this radical, you're going to go 25 to the third power. What did I get? I got 15,625. Then I took the square root of it, and it came out as 1 over 125. Okay, not too bad. All right, example number 3. Let's go medium. We're going to simplify the fifth root of 729. Okay, 729. Now, most of you are very familiar with perfect squares, right? And you can name like most of the perfect squares, like 1, 4, 9, 16, 25, and you can spot those pretty quickly. But can you spot your fifth powers?
7.
One way to guess is to look at this number 729 and realize, okay, it's going to be a number that's a lot smaller than 729. And maybe start with like 5. But it doesn't end in a 5, right? Because anything multiplied by 5 is either going to end in a 5 or a 0, right? How about 4? Is it likely that 4 is a factor of this? No. What about 3? Is it likely that 3 is a factor of 729? Does anybody know the shortcut to see if 3 is a factor of a larger number? Yeah, so if you add 7 plus 2, you get 9, and then 9 plus 9 is 18. Is 18 divisible by 3? Yes. So we can actually rewrite this as the fifth root of 3 times 3 times 3 times 3 times 3. How many do I got? Times 3. It actually is 6 times. 3, 3, 3, 3, 3, 3. You did the prime factorization. That's what you'd get. Okay? Which is the fifth root of 3 to the 6th power, but we only want the 5th root. So we take out 3 to the 5th, and the 3 comes out front. And how many do I have left inside? Just 1. So we leave that 3 to the 1st under there. And you can write a 1 if you want. Or you can just write 3. Okay? You guys ready for a harder one? That's the answer. That's completely simplified. You type this into the calculator, you get a decimal. And you cannot do decimal at this point.
Is there any way to get it to come out to a square root? Like,
Well,
if you enter a square root, it'll come out with, like it'll come out.
some of them will, I suppose. So like if you had even roots, so like 2, 4, 6, 8th root, that could help you get there. Does that make sense? Okay. All right. Example number 4. We're getting into the harder ones because, you know, in your book it's going to start off easy, 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 and then get to some harder ones. We've got 81 to the negative 5/3 power. Which, since it's a negative exponent, I'm going to make it into a fraction by putting a 1 in the denominator and then flip it to 1 over 81 to the 5/3. Okay, so let's rewrite that with the 3rd root and then 81 to the 5th as our radicand. Okay, but we only want a 3rd root. So 81 to the 3rd could come out, right? But remember the weird little rule, like you can't have radicals in the denominator? You guys remember that rule? Okay. You have to rationalize the denominator. So the easiest way to get it out of there is multiply by the 3rd root, and you guys are used to doing it with 2nd root, so it's a little weirder with 3rd root. Okay. What is the next closest multiple of 3?
What?
To 5. 6. So how many more 81s do I have to multiply to get to 6? Just 1. So 81 to the 1st, which would get me 6, and then I can take out 2 3rd roots. Whoa, right? Okay. So in the numerator, we also have to multiply by the 3rd root of 81 to the 1st. Now, most of you recognize that 81 is 9 times 9, but it can also be rewritten as 3 to the what? 3 times 3 times 3 times 3, right? So 3, 3rd root of 3 to the 4th, and then in the denominator, we're going to take 3rd root of 81 to the 6th, because now I can add those two exponents. Okay, so let's deal with the denominator first. So we want the 3rd root of 81 to the 6th. Remember, there were 2 of them. There was 81 and 81. We'll multiply those in a second. In the numerator, we've got 3 to the 4th, and we want the 3rd root. So how many 3rd roots do we have in there? 1. So I'm going to pull out 1, 3, and 1 left inside. If I multiply 81 times 81 with my calculator, I get 6,561. Is it likely that I can reduce the 3 and the 6,561?
Oh, yeah.
Yeah, because if you add all these numbers together, they're divisible by 3. So that reduces to 1 over 2,187. And then we have just that 3 root of 3 left.